Data-intensive applications like AI are fueling intense demand for more advanced computational capabilities. As a result, chip makers are pushing the limits of what's possible in the race for the next generation semiconductor devices. Atom-by-atom deposition of metal is essential in manufacturing these advanced chips, from creating complex patterns to memory word lines and to logic contacts. And tungsten has been the metal of choice for more than a couple of decades, but traditional metallization schemes can no longer support this kind of aggressive scaling demands. With this in background, Lam Research recently introduced Altus Halo, the world's first atomic layer deposition tool that harnesses the capabilities of the metal molybdenum to enable scaling in the AI era. My colleague Ross Young had an opportunity to sit down with Kaihan Ashtiani from Lam Research to learn more about this innovation.
Hello, Kaihan. Thanks for taking the time to meet with us today. Tell me a little bit more about what you do at Lam Research.
Yeah. Hi, my name is Kaihan Ashtiani. I'm Vice President, General Manager of ALD CVD Metal Deposition Group at Lam Research. I've been with the company for 27 years. It's been a fun journey.
Please explain the role of deposition in semiconductor manufacturing.
Yeah. Deposition generally refers to forming thin films on a semiconductor chip. Those films generally come in two different categories, dielectric films and metal films. And the idea of having two different films is to form the interconnects that connect billions of devices on a semiconductor chip such that they can talk to each other and perform the function that they're supposed to do. So dielectrics provide the insulation, just like wiring in our homes, and metals have the role of carrying the current, electrical current in these devices. So we deposit these films via PVD, CVD, and now ALD. The difference between ALD and PVD and CVD is related to the precision of how we deposit the films. So CVD refers to chemical vapor deposition. It deposits film at a much higher rate and faster rate and deposits bulk material into devices. PVD refers to physical vapor deposition, where a target is used of the material that needs to be deposited on the semiconductor chip, and that material is transferred from the target to the wafer. So both of those techniques were viable when people were looking at very high dimensions of the features in these semiconductor chips. As the dimensions shrink and get smaller, we need a more precision or precise method of depositing these materials. So with the metals, atomic layer deposition, ALD, is used such that we deposit these films one atomic layer at a time on a semiconductor chip, therefore achieving the precision that we need to fill the dimensions that are getting smaller and smaller. So it's something that Lam started more than 20 years ago in terms of developing the atomic layer deposition. And we were the first company actually introducing ALD of metals in the industry with our ALD tungsten. And now we are transitioning to ALD Moly, which is a very important, significant point for the industry to shift.
So please tell us a little bit more about why Lam is transitioning from tungsten to Moly.
Yeah, so when we look at the technology roadmap that our customers have in terms of advancing their devices to address the needs of the industry in AI, in cloud, in high-speed I/O, all the applications that are very demanding from a computing perspective, there is a need to lower the resistivity of the metal that they use for the interconnect. And Moly is able to address that compared to other materials that have been used in the past. So resistivity is a very important part of metallization in semiconductor chips. And as the name says, resistivity is resistance towards the flow of electrical currents, which determines the speed of the device, therefore performance of the device. So this transition to Moly is very important from that perspective because we offer lower resistivity metal compared to what is used today, such that our customers can advance their devices to the future.
What devices are you expecting to use Moly first?
Yeah. So there are two questions in that. I think it's what devices need to use Moly and which ones are going to happen first in terms of adoption. I think from a device perspective, and we see that in the industry today, is that literally all devices and all customers are looking into this transition to Moly. But in terms of adoption, the timing is slightly different, even though they're close enough that it becomes a challenge to some degree. I would say literally all devices will shift towards Moly. From the priority perspective, in terms of adoption, perhaps the NAND in memory is the first adopter, and it's going to be followed very closely in logic and DRAM.
And which is the most challenging to adopt?
I would say most challenging perhaps is NAND, and that's because of the way the device is laid out. NAND devices are formed in 3 dimensions and have a 2-dimensional aspect to them as well. That makes the surface area that we need to deposit the Moly film into a very large surface area with the challenges of different aspect ratios, both in vertical and lateral dimensions. So because of that, the process sequences that are required to do Moly deposition in these devices, as well as the hardware features that are necessary to make the process happen, is more sophisticated than the other two. Even though the challenges of integration remain for all devices, logic and memory being NAND and DRAM, those challenges are unique to each device. So we have to address all of those independently.
So why is Lam best positioned to lead the transition to Moly ALD?
Yeah, I would say that over the past 20 years, we have introduced technologies in terms of atomic layer deposition of metals that have been pioneering and leading in the industry. So 20 years ago, we came out with our atomic layer deposition of tungsten, and that started being used in high volume manufacturing. So I would say that leading position that we had in terms of ALD deposition of metals, it puts us in a very good and significant position to have a leading position in ALD and Moly as well, which shows in our adoption of our Halo Moly today in the industry.
So it's going to be tough for your competition to break into this segment.
I would say that we have a good lead over our competitors. This is a significant inflection in the industry, and I'm sure our competitors are as hungry as we are in terms of developing these technologies. But in terms of our lead in the area, in terms of the technology that we developed, and also with the Moly itself, where we started close to 10 years ago, that we have a significant lead in terms of development of technology. That I would say that we are in a very good position to lead the industry.
And how is it deposited? Is it a gas? It's not a target? So how do you source the Moly?
Yeah. The Moly is sourced through a chemical precursor. So the chemical precursor comes in different forms, as like any other chemical component or precursors. There could be different composition. We developed those techniques starting, I would say, close to 7 years ago with some of our vendors developing those techniques to deliver the material to the chamber such that we can run the processes and deposit the films. So, and we've made significant improvements and advancements in delivering these materials.
Is that another competitive advantage for Lam?
I would say so, because there's what we call the bulk delivery first in the industry at this scale. So we developed a delivery system that goes in the sub-fab of our customers, not the main fab, where usually the chemicals and the facilities are supposed to be, and then it's delivered to the tool in the fab itself. This was, I would say, a first as well, given the scale of the material that we are putting down. So, and I would say that is competitive advantage for Lam as well.
So it takes up less clean room space.
Correct.
And what was the role of your customers in defining the requirements for this tool?
Yeah, so we developed this process, what we call the unit film, and the tool. We started developing it starting 10 years ago. So developing the unit film is one part of the process. to make these materials be accepted in the industry. Next is to put it at our customer sites and look at the integration of this film with the rest of the device, and also validate the economic viability of the tool. So we started that development, but we needed a collaboration with our customers to validate what is the rest of the environment that needs to support the deposition of Moly. And that's what we've done with a number of customers over the years.
What can you say about what this tool means for your customers' roadmaps?
All customers look for advancing their devices. Part of the advancement of devices is related to making metals being lower resistivity, essentially having faster speed. So on their roadmap, there was an anticipation of the need, but whether Moly or other materials could satisfy that's the big question that vendors like Lam address. So we've addressed that part of their technology roadmap, that they would need a lower resistivity metal, and we proved out that ALD Moly could satisfy those requirements that they have. And now we have the validations that, in fact, we were correct in our prediction that Moly is the right material to address those challenges. This is a significant inflection in the industry. It obviously enables our customers to advance their technology, given the acceptance and the shift that we are seeing from other materials to Moly. It creates, obviously, an opportunity for Lam to participate in this inflection in a significant way, and for our customers also to show the benefit on their devices for their customers being either consumers or enterprise. Either way, they're able to demonstrate the benefit to their customers as well. So I would say it's a win-win situation for all in a very significant inflection in the industry.
When do you think we'll see the first Moly ALD devices in the market, or are they already out there?
I would say most of our customers are in various stages of development right now. And that means certain customers may be at the very beginning of that validation. And some customers we are already seeing in ramp and close to production.
Well, it must be very satisfying to see something you've worked on for so many years come to market and will be in consumers' hands.
Absolutely. It was a great challenge, and we are happy that we are addressing a need for the industry, while I think both us and our customers will benefit from.
Seems like a real breakthrough. Is there anything else you'd like to add?
I would like to come back to saying that we've enabled deposition of Moly via atomic layer deposition for the first time in production for our customers. And that's a significant shift from the metallization schemes that we've had before. And Lam is leading position to take our customers through this journey and make them advance in their customer needs and advancing their devices, as well as moving the industry to the next phase.
Very exciting. Congratulations.
Thank you so much.